Thank you. Okay, great. Um, okay, let's get started. So my name is Joe from Walt. I started a small software company a couple of years ago. So we've been in the tech space for 10 years, and AI is really disrupting our industry. So I was thinking about a topics that we could discuss, and just if AI is actually thinking. So let's get into it. Okay. Okay. So funny thing happened to me over the weekend. I've got a couple of mates that's really into schoolboy rugby, and we were deciding. I was trying to get a crowd together to go and watch a game for Office. I don't know if you guys know Office. So I was looking at max fixtures. Thought I'll just ask the AI to tell me if there's a game over the weekend. This is what it came back with. Um, so so it said Afrikaans School versus Polaris. It's a good game. Polaris is also one of the tight hits. So I thought this is great. Actually, hold on. Okay, there we go. Um, and it came out to this kind of blurb, gave me the details. Saturday, 28th March. It's great. Um, Even gave me the rugby festival. Even gave me this little bit of text to say, yeah, it's one of the great fixtures. It's like all primed. Let's go. Looks correct. Everything's great. I took this piece of blurb that came out of the AI, sent it off to one of my friends that was actually in Office, also big into the rugby. He came back with this. He said, yes, Joe, Paul Roos was, so I'm going to read it in Afrikaans. So he just said it was yesterday. That was the like last week, and he said that they actually lost to Paul Roos. Um, Clearly, the AI just dreamed up this thing. Now, what I realized later on is I actually went and looked for this North South Rugby Festival. It's hosted at Office, but they're not actually playing Paul Roos. Paul Roos is there, but they're not playing it. So this is just one example of what AI does today, right? So it builds up a seemingly well-informed answer, and it's plausible. So you could, if you look at it, you think this is completely normal. This is a correct thing, but actually the nuance is that the the rugby festival is hosted at Afrikaans Tour, but they're not actually playing all the rest. So, yeah, so that's going to be keep on pressing the long one. Next, okay. So that's what we're going to be talking about today. Is the AI actually thinking? And there's a lot of hype around how AI works and how it's supposed to be like a human, um, but it isn't actually. And we're going to talk about that today. So I'm going to just start off with and trying to be not to be too technical, just how machines learn. So how does it actually work? The basic, why language is hard, why that has changed in the recent past, what changed, and then just how Gen AI works as opposed to normal prediction and things. So, okay, let's get into it. So the first thing you have to understand is that this whole thing AI is just maths. It's not actually thinking like a human. So it's not a human brain, right? Even though our friends at OpenAI and Claude and all of those would like it to think it's a human brain, it's not. It's just maths, statistics. The first thing you have in maths is a function. Function is pretty simple. So it starts off with you've got an input, so some kind of a input, and then you've got a transform and an output. So example would be a simple transform would be the input would be 3 times it by 2, you get 6. So input, transform, output, that's a simple function, right? So if you elaborate a bit, it's just like a calculator. That's essentially what it is. That's how you basically a calculator works. So then the next thing that if you want to build an AI machine or that can that looks like it's thinking, is you need weights, right? So weight. If you've ever done a performance review, the scores they associate with each question, that's essentially a weight. It just shows you how important a specific question or something is. So now we can evolve our little simple function to something more elaborate. Start off with an input, and then instead of just the transform, we've got a function plus the weight, and that can give us a different output. What can we do with that? So typically, what that allows us to do is to make some kind of a decision. So let's say I'm buying shoes. I would go and I'd say, okay, let me just stand this up. Everyone can see. So let's say I'm buying a new pair of shoes. Typically look at the price, look at the color, maybe the style. Depending on the weight I put to each one of those, it lets me make a decision. Either buy it, don't buy it. That's simple weights plus a function. So we've got a function that inputs, scores, calculates, and we based on weights, and then we've got a decision. So now imagine let me stand this side again. So at the moment, we've got one decision. That was a simple one decision buying shoes. So weight, score, decision. Okay. Then we can go and we can stack multiple decisions. So we can do a bit more complicated decision planning. So that would be your performance review. So decide on a bunch of stuff and then add maybe another questionnaire. So we almost stack those decisions on top of each other. And then, so in the AI world, and look, this isn't a super technical talk, it's just conceptually, they refer to these things as layers. And you can have many layers. As most AI models that we interact with, ChatGPT, those things, they've got millions of layers that it pushes through and then makes a decision. And what you call that whole thing is a neural network, right? So just be careful for the word neural network because, again, it applies a brain, right? It's not a brain. It's just a combination of maths that feed into each other. Okay. That's typically what a neural network looks like. They modeled it on how we think the brain works. It's not actually proven by science, but this is how we think the brain works. It's got an input layer, got a bunch of nodes, and they refer to these little circles as neurons, right? So using that language, and in the past they did that because it just created hype. People were thinking, okay, artificial intelligence, the robots and everything. Okay, so now I just want to quickly talk about language, right? So in the terms of, so we've been talking about maths, right? So how do we now model language onto maths? And you'll see it's pretty hard. So if you look at this sentence, you fed a dog biscuits, okay? Good me. So what is it? Is he feeding a dog or is he feeding her dog biscuits? You'll see the nuance there. Same sentence, two different meanings, right? You're on board with that. That's what makes language complicated. And the difference between the two is what we refer to as context. So you have to read language in terms of a certain context. So if you know these people, then you automatically know that you're not feeding her, you're feeding the dog. Or maybe you are feeding it. Anyway, okay. So what happened was, so this tech, by the way, up until now that I've explained, has existed for many years. I think the first models were proposed in the 1940s. They started an official AI division for studying machine learning and those kind of things in the 50s. So it's old. Tech is actually old. It seems like a super new thing. It's actually pretty old, the mathematics that goes behind it. The difference between then and now, in 2017, there was a change in how this works, right? And that's the architecture of how this works. So the breakthrough came in the form of transformers, and those transformers were conceptualized in a white paper by Google, and the white paper was called "Attention is All You Need." So they introduced the concept of a transformer, and that allowed many other people. So it's open. You can go and read the original white paper today. Most AI that we know and I'm talking about language models. So the stuff that everyone uses every day. That kind of AI, this transformer architecture was critical to that, right? So before transformers, models read text sequentially, struggled with relationships, didn't scale well, right? After transformers, we get parallel processing, new capabilities at scale, and we get massive scaling. So they were able to process a lot of text data to build out the models. Now, if you remember correctly, I explained the weights, right? So model is actually just a bunch of pre-calculated weights. That's all it is. Okay, hacker. Um, so now I just want to quickly talk about how this works, right? Specifically in terms of language, right? So you've got this idea of a next word prediction, right? So what the AI is doing is it's just predicting the next word that makes logical sense. I'll quickly give an example. So, see, so let's take a sentence. The CEO walked into the boardroom and, okay, so we can automatically assume what it does next. Your brain does it, right? So it might have sat down, started talking, I don't know, reprimanded someone, something like that. So some examples. So if you look at how AI models are predicting things, right? It just runs on a weight. So it'll say maybe 30% chance you just sat down, 25% chance you started speaking, and another 15% chance. And then it'll just, so if you look at maybe ChatGPT, it'll just choose the first one, sat down, give that back to you, right? Okay. So I use the word next word prediction, but it doesn't actually, the correct term is what they call tokens. Don't have to remember this, but you'll hear the word tokens. If anyone talks about AI, they'll talk about a ChatGPT is a 5 billion token context window. Quickly explain what it is. So um, if you look at that sentence, the CEO walked into the boardroom, you can break it down into little words. So, and essentially what it does is it converts those words into a little piece of math, right? Now, different AI models work differently. So they all typically go and um, use these tokens efficiently. So it might be walked, and determine what the token is in a different manner. So if you're using Claude code, uses different, all of that. So, but essentially what it does is it just takes that piece of text, breaks it down into little tokens, which can then be coupled to a mathematical formula. Okay. Okay, so the meaning of these words become numbers. So as I said earlier, so a neural network is just a bunch of mathematical equations. Okay, based on probability, it can go and predict stuff. Um, so each token's turned into numbers, like I said. So here's something that's very important is how it works and how it knows how to predict the next word is it'll go and group the meanings of different words together. So if you look at, let's say king and queen, semantically, it's got a closer relationship than cat and dog, than something like a cat in a spreadsheet. So you can always look at this graph. So king and queen together, cat and dog together, both animals. So there's these relationships between each other, like distances almost. And that and the technical term for that is vectors. So it's vectors between words. So when the AI, when you reach at something like a king, then it automatically knows that queen is fairly close to king. So it keeps that in mind when predicting new words. Like, okay. So then just want to quickly talk about something else, another concept. Just want to check the time. Okay. So something that people don't realize with these LLMs, right, is that they don't actually have a memory like a human. So if I tell a human, listen, I bought fish and chips at the shop yesterday, it remembers this. But you must remember that these functions work on the weights, right? So the weights are the probabilities of things, and those are calculated in huge data centers. It takes, I think, GPT-4 took about 4 months to process and to tune. So it's a once-off static set, right? So if you want to have the model understand what you mean, you have to give it the context. So let's say I want to ask it, should I make a career decision, right? I first have to tell it, listen, my name is Joe. I work at Code. I want to go into actuarial science. I have to give it all that context and only then ask the question. What happens with ChatGPT is OpenAI has done some smart work in saving that context. So if you talk to it, they save it offline, but it's not the actual model that remembers. So it doesn't remember. A lot of people are afraid that if you type something in there, the model automatically learns these new things about you. It doesn't. It's OpenAI that just stores it in a database. So so that's the context. So and there is a limit to the context. So if they talk about a 50 billion token context window, all that means is that how big is um, the model's brain to take in information that it's not been trained on. So that's why you would see if you put a huge document into it, it might either run out of tokens or it starts giving you weird results. It's just how big the model is. So all your frontier models, that's the thing that the AI companies are increasing, is that the amount of parameters that it can process. Um, yeah. So like I said, that's the context. So if you think about it, so we've gone through everything. So we've got the functions, the math, right? Then we give it context to fill it out. Okay. Then I just want to quickly talk about attention, right? So what makes our AI today feel so amazing and that it's like a human, right? Is this thing called attention. And I referenced it in that Google white paper that they wrote. So what they did that we didn't do previously is they said, okay, so we'll take a block of text and then we'll look at the most important parts of that text based on algorithms and we'll pay attention to that. And then once we've done that, the model will go and then predict what its answer is supposed to be. So you must see how it works. It's not that it thinks. It goes, uses the context, runs a bunch of mathematical formulas, and then it guesses. Not supposed to use guess, but predicts based on probability what it is that you're actually looking for. And it's very good at it. I mean, it can predict that you're looking for a specific piece of code, a chicken curry's ingredients. It can go and predict where your kid should go to school, but it just uses the context and its model weights to do that. It's not actually thinking. It seems like it is, but it's a magic trick, essentially. Yeah. So the one difference that we have with attention is it also gives us the ability to readjust the weights based on whatever's been said. So it'll look at the context that you gave it. So it'll say, I'm Joe and I'm, I don't know, a plumber. And then based on that information, it would pay attention to that, readjust the model weights, which gives you this supernatural prediction of text. So that's just how it works. Yeah. That was a breakthrough, by the way, by Google. They built this into it. So it focuses on what matters at the right time. So when you're busy asking it questions. Okay. So, no, actually spoke too fast there. But anyways, okay. We can do some questions, I think, if you guys... Is there anything, by the way, you guys want to ask a question? Is there anything that I've, like, because I went through everything pretty fast, quite dense topic. Okay. I'll hit the summary. Okay. So just in terms of how language AI works, and remember there's different types of AI. What I'm referring to here is the stuff we all know. Okay? There's other things as well, like predicting pricing and stock markets, not really stock markets, but classification and those kinds. What I'm specifically talking about here is how text-based AI works. So you're using ChatGPT or a coding agent or anything like that. It just predicts the next token, uses the context to do that, and then based on the relationships between the words, it'll go and do this amazing thing. So just my final note. So is it thinking? So I think what I've tried to explain is that no, it's not thinking, right? So there's a lot of talk about AGI, the Terminator series where the robots wake up and do all kinds of stuff. We're far along from that. We're still far away from that. There's a couple of critical things that still need to fall in place, which seems like it would happen soon, but it's not. It's not thinking. It's just using math. It's essentially a huge calculation machine. Um, it's predicting using a lot of data. So there's actually quite a lot of people that are worried now in the world about what AI is just doing to our, even not using the AI, just what it's doing to our economies. You know, there's a huge chip shortage. Um, the reason that is it's consuming a lot of resources. And firstly, power. To train these models, you need a lot of data and you need to run processes continuously. You have to cool those processes. So it uses power, water, and it also, the funny thing is that it's also using a lot of money. So you could think of how we should have been spending that if you just look at the world, and it's driving into this imperial. So that's just what it does. Uses a lot of data, then processes that maths before actually using it, and then it's just maths all the way down. Yeah. Any questions? Hopefully, yes, go for it. Thank you. Uh, I ran to the ticket. So, Turkey. Yeah. Yeah. Heavy of this topic, say to keep saying. Yeah. That, so there's a couple of things that happens with that context. Okay, so let's just remember again. So what actually happens is that as you talk with the AI, every time you say sing, it takes everything you've said, compresses that, loads it back into the context window, and then based on that, it predicts what it should say. Funny thing is that that's an interesting case study that you mentioned. That happens with so the first thing it'll do is if that window gets full, it'll start forgetting stuff. So if you, let's say you've got a chat window open on ChatGPT and you mentioned something to it last month, okay, and now you've continued chatting, it'll just throw that information away unless it's a poor memory where OpenAI will remember it, right? It'll just forget about those things. And then the other thing is in the middle of the context window. Okay, so let's imagine a sliding window, start to end. It's throwing away all the stuff that's in the past, and then in the middle also doesn't predict well. That's one of the challenges that they're facing. So if you want to get the best results out of it, just use smaller context window. Don't give it too much information, just enough so that it can make the prediction properly out. Cool. Um, anyone else? Yeah. Thanks, Greta.
So we covered that I have one fee and
Thanks.
but then it is and what happens in the chat PM there's legal says legal reasoning.
It's not reasoning, right? They say it's reasoning, but what actually happens is that you can run prediction. So what you can do is you can take a model's output, right? So you ask it a question, then you can take that output and feed it into another model that's specifically trained for validation. And you can say, is this correct? And then that validation model would go and say, listen, it's not correct. This isn't 100% right? And it could feed it back into the regional model. So it's almost, think of it as multiple AIs talking to each other. So they can do that. Not really reasoning, still math. And it's, so think of a loop, right? Start with the original question, then get an answer, then you pass it to a different type of model, and then if it's correct, then it'll feed it either back or give the user the answer. Now, a good example of how these multi-model things work is if you take ChatGPT today, you can do some cool things, right? So you can go and say, generate a little image for me, right? Now, if you think about it, there's two models that, actually three models that theoretically works there. The one model just decides what is the user actually asking, and then it says it's actually the user's actually asking for an image, right? So I can't process it with text. I need to process it with some kind of an image generation tool. So then it pulls up a different model that generates specifically built around building images. And it kind of does that. And then you've even got a model that verifies whether the image that was generated doesn't have some kind of a nudity or some other strange thing in it. And then verifies that image that it's actually what the user was asking. And it can regenerate again. So you'll see with the image generation, it kind of loops a couple of times. It takes a bit of time to do that. So you've also got those. So thanks for the question. You've also got that option where it does research. And what the AI does is it goes and loops, say, 15 times, just validating answers. And it can even pull out into the internet to go and read blog articles, consolidate the view, and then add someone that evaluates it. So yeah, thanks. Yeah. Thanks for the question. Any other ones? Still got a bit of time. Yeah. Thanks for asking questions, by the way. I spoke too fast. I even told Sarantis beforehand. I tend to do this when I get nervous. I just ramble on.
Okay, so our question is, what is the difference between the necessity listed that are calculating now the pure version versus a paid version? So it's something talking about the context of the spots. Like a does separating our response.
Yeah. So look, I've been using the paid version, but I do know they introduce a bunch of restrictions, right? So the first one is that they limit your token count. Okay, so just to make it easy to digest, the amount of words that you can give the AI model. So you'll see what happens is you asking it a bunch of questions, and then eventually it'll tell you you've reached your limit. That's literally the amount of text words that you gave the thing. Um, Tokens don't 100% translate into words, but similar to the word, the amount of words. So then you run out, you have to pay. I do know in the past what they did was they also didn't give you access necessarily to their frontier models. So they'll just give you a model that's reasoning capabilities are less than the ones that you get on the free version. So how that works is that, remember I said you've got those model weights. Uh, so what they just do is they just give you a model that doesn't have those many parameters, or it doesn't have the same large amount of context window to process. So those are the things. And then they've got other features. So ChatGPT specifically, they've got that research mode where they combine the AI. You don't see it as a user, but it's doing it. You'll see on the output, it'll write, checking this, now referencing this website, looking at this document. You don't have that. So they limit those kind of features in the freer versions. Yeah. So you also, I don't think there's OpenAI has also got a coding agent for Codex, which I would recommend installing and playing around with because it can work with files. Right? I think that's also limited in the free version. Yeah. Any other questions?
From a SAPHEX specialist, it's AI auto mechanics.
No, they're not. So, yes, good question, by the way. So, they're not deterministic. So, just to explain how I understand determinism, is if you ask the AI the same question twice, right, does it follow a logical conclusion, right? So, if you ask it, simple math, it's not a good example, but let's take language example. So I'll say, I want the recipe for chicken curry, right? It might produce a result for ingredients and how I should cook it and what the flavors are. Then I ask it exactly the same question, different recipe, different way to do it. And why it does that is there's a certain amount of randomness that they build into the models. And they do it on purpose, by the way. Otherwise, you don't get creative. You can't have creative works. That's why. So if you ask it, say, generate a picture of a wolf, and then you ask it exactly the same question, generate another picture of the wolf, it will always generate a different, and that little piece of randomness is called the temperature. So not the same as lower temperature. it's just the amount of randomness that you could feed into the model. And now, if you're using ChatGPT, that temperature is fixed. You don't even realize you're using it, but it is frustrating. So let's say I'm sorry, for example, I'll be coding up a little computer screen. Then I'll go and tell it, listen, generate a button with a screen, right? Generates a bunch of text. Then I'll ask it to add another button. It would use a completely different methodology, completely different way of working, mess about with your code base, and then you have to refactor it. So yeah, it's not deterministic. That answers your question. Yeah.
I mean, in exchange that I'm not sort of dealing with this sort of menting about the idea of quality.
Yes.
Is from a reliability perspective that if I'm using AI to do something creative, but the reliability maybe okay, but if I in a highly sensitive space, the quality consistency is important. How do you manage this variability in AI?
Yeah. So there's two ways to do it. Look, I mean, this is a specific research topic in AI at the moment, right? There's a couple of things that they're looking at, pouring millions of dollars into it. Is the first thing is actually more serious. It's safety, right? It's set for the business concern. Is how do you prevent the AI from divulging a way to engineer a COVID virus? So they're busy working on that. The current thinking is that, unfortunately, you always have to have a human in the loop. So it's good news for us developers because you still need a person to go and verify. You have to verify the output. Someone needs to check it. Specifically in coding, right? In software development, there's a discipline it's not practiced often because it's so expensive and only a certain amount of people in the world can do it, where you can mathematically verify programs. That's an exciting field of study that they're going to use AI to assist with. So you could get the AI to generate the formulas to verify whether your process is correct mathematically, and you can always check the math. So it can either work or it can't work. So that's one way of doing it. But the current recommendation is always have a person to verify the output. And the unfortunate thing with AI is, you'll see with my first example, is it looks plausible. So there's a trap there. Looks plausible. So pay attention when you're reading AI generated feedback. Yeah.
Maybe just one last person speaker. Help me or anybody at OpenAI actually knows what's happening to these five get body.
No, they do not know. So that's a good question. I should have added that in the slide. I'll remember for next time. So if you look at how an AI model is built, the machine learning, the maths, and so it's billions and billions of math with equations that are evaluating weights and feeding into each other and things. If you had to write that out on a piece of paper, so let's say you ask ChatGPT a simple question. Let's take my chicken curry example, and you tell it, listen, output all the math that you use and including the training to get to this answer. You write it on a piece of paper. You basically cover the whole world. I don't even know if you would cover the whole universe in paper. It's that many calculations. So it's impossible for humans, to go and look through all that math to actually see what it's doing. So essentially, it's this black box, calculated weights, and you kind of have to check whether the answers are generated, but how it generates the answers and how it got to that specific percentage of the weight, still no one knows. There's a cool example that they did. They built a little AI that got trained the following way. What they would do is they would take images of people, right, men and women, okay, just of their eyes. So it's no way to see if it's a man. So a human can't see whether it's a man or not. And then they would feed the images into the AI. It was what's the name, a manually trained AI, not self-trained. And they would go and say, okay, this is a man's eye, this is a woman's eye, this is a man, woman, and they'd say, and let the AI guess and build up weights. Eventually, the AI could, just from an image, determine whether this eye belongs to a man or a woman. And to this day, they don't know how it does it. So it knows it. It's accurate, okay, considering now temperature and all of that, verification. So let's say 98% of the time it's accurate. But how it determines it, no one knows. So, yeah.
Good job.